My name is David Mikhail. I am a recent university graduate from a US university called Minerva, and I studied data science and neuroscience. I'll be starting a PhD in bioengineering at UC Berkeley this fall. And I would like to thank Neuromatch Academy actually, because I was a student here 2 times before in 2020 and 2021 in the computational neuroscience track. And this is when I developed the interest for using computational tools and machine learning and neuroscience research and with brain data. I use it in my research today, and I plan to use it in my PhD as well. I'm here today to talk about polynomial regression, which is a statistical technique that's considered an extension of linear regression, because linear regression has this assumption that the data is linear, so we can only model a straight line to fit the data. But some data is actually not linear, so we need a more curved line, or the data can only be modeled by a more complex relationship if we actually need to model it accurately. This is when we can see that it's useful to use a polynomial regression, although it can be more computationally extensive. So it's useful in cases when the data is like brain data, for example, or complex biological systems, where you know that the data is not linear and you want to fit a more complex model to this data. And we do this by creating something called the design matrix, which is essentially raising our input data or the independent variable to a power of 2, 3, or 4, or 5, depending on something we call the order or the degree of the polynomial. A polynomial of a degree of 3, for example, will have a linear term, quadratic term, and the cubic term. If the data is more complex, we fit it to 4 or 5, and etc. So in that case, we have a column of A, a column of B, which are two different features in our data. And then we raise A to the power of 2, we raise B to the power of 2, and then we have an interaction term called A times B to model the interactions of these variables if it actually exists. And this is called the design matrix. And this is what we will be trying to create right now in this line, in this code cell here. We're trying to make a design matrix, as the function name says, that takes as an input the X, which is the data that we created for the purpose of this code, in the some code cells above. And then an argument is also the order of the polynomial, which, as I said, to what power you want to raise your data to. Let's first comment this out to not produce an error. So in line 18, we are basically checking if the input array X is one-dimensional, is a one-dimensional array or a vector. In this case, we reshape it to be a two-dimensional array with a column, like with only one column. And this will be useful to later stack the other columns next to it. And as you can see here, for example, if A is the only feature that we have, we want it to be in this shape, one column. And then in line 23, we initialize the design matrix with a column of ones. Remember, we start with X to the power of 1, to the power of 2, 3, but the very beginning it X to the power of 0, which is always 1. So we start with this column of ones, which is also the intercept of the curve that we fed with the y-axis. So this is what we always start with and how we initialize the matrix. After that, the main part of the code, we loop from degree 1 to the order of our polynomial. We add +1 here because in Python, it subtracts 1 from whatever we put in the upper bound of the range. So to end with 1. And then what we want to do is in each iteration, we want to stack a column of X raised to the power of that degree. So for this, we use the function called np.hstack, horizontal stack. We always start with our design matrix, which we created with a column of ones. And in each iteration, one more column is added. And then we add X raised to the power of the degree of that iteration. And we return the design matrix. In this example, the order is 5. So we'll go up to X to the power of 5. And then we call the function. And then here I want to output the first 3 columns. So we can see here column of ones, and then X to the power of 1, and then X to the power of 2. So this is how we create a design matrix, and this is what polynomial regression is all about. Thank you.